Welcome back. In this video, I'm going to show you some tweaks you can make to the Finch Remote Robots server files to do things like have students control more than 3, like up to 6 robots, or possibly also change some things to tweak the files to more closely meet your needs. So the first thing I'll show you is how to make it possible to control 6 robots. So to do that, I'm going to go to my Finch server file. So this is Finch server A. And it's actually quite straightforward to make more of these. All I need to do is, to make a file for like robots D, E, and F, I'm going to change microbit print A to D here. I'm not going to change which Finch I'm connected to, and I'll explain why in a minute. And then I'm just going to go into Save As and save this project as multi-Finch server D. Then I'm going to go to server B and change that to E. And again, save that as multi-Finch server E. And now I'm going to go into C, and C is going to also be my server for F. So I'm going to change, again, changing it to F and then saving it as multi-Finch server F. And there we go. So now I have my 6 server files. So now in order to make this work, in a setup with 6 robots, I would need to have 2 laptops because you can only connect 3 robots to 1 computer at a time. And so I would turn on robots A, B, and C and connect those to my first computer, and then connect them to the Bluebird connector in order A, B, C. And then I would run server files A, B, and C on that computer. Then on my second computer, I would load server files D, E, and F, and then I would turn on robots D, E, and F, and then I would connect them to the Bluebird connector of that computer in order where the first robot I connect is going to be robot D, and you'll see on the Bluebird connector it'll call that robot A, and then I'll connect E, and that will be robot B for the Bluebird connector, and then robot F will be robot C for the Bluebird connector. But because I'm running multi-Finch server D, E, and F on that computer, those will kind of map to robots D, E, and F that I have here. So that's how to get 6 robots working. It's actually possible to extend that beyond 6 as long as you have 1 laptop for every 3 robots. You could basically go to infinity. But if you do more than 6, you'll also need to make changes to the remote Finch client file that you sent to students. And I would be thrilled actually to help you to do that, because I'd be really excited if somebody was actually controlling more than 6 remote robots at once using this kind of technology, this kind of setup. So you can contact me at tom@birdbraintechnologies.com if you're interested in how to tweak it to go even beyond 6. Some other tweaks that you can make to the server file. Let's just go over here again and take a look at it. So if I scroll down, I can see that there's something called a timeout loop. Now, the way we have this set up right now is if a student doesn't send a command, so doesn't click on a block or run a program for 5 minutes or 300 seconds, the robot will time out and revert to being available, so connectable by other students. And that's so that if the student closes out of the window without disconnecting, you're not left in a situation where the robot's just unavailable forever. If you want to make that more aggressive or less aggressive, you can change this number 300 to however many seconds you want that timeout to be. So that's one pretty simple tweak that you can make to the server file. Another is the speed commands. So because we are running these in a pretty small arena, 4 feet by 4 feet, I'm actually speed limiting the Finches. When somebody sends a set wheels command, I'm actually dividing it by 4. So if you look at this is where the wheels message is getting received and then sent to the Finch. And again, here's a divisor dividing by 4. So if you want the robot's max speed to be higher, you would change this divisor. So again, right now, if a student says, move at 100% speed, the Finch is actually going to go at 25% speed. You can make this 2 or even 1 if you just don't want to do it at all. For the move and turn blocks, I'm doing something similar, but I'm only dividing the speed by 2. Something that you could put in that I haven't put in is you could also put in like a max distance, right? So you could say if the distance is greater than 50 centimeters, set the distance to 50 centimeters or cap the distance command at 50 centimeters so that we're not telling the robot to drive too far. So there are other things that you can do to change the code here. It is just a blocks programming environment, so it's quite accessible in terms of what you can do. You'll notice that each of these commands happen when I receive something. And this is an event, a network event. And the other side of that, I just want to show you just to give a little more insight into kind of how these work. So this is my remote Finch client. And if I right-click on a move block and hit edit, I can actually see what's happening on the client end. So it is, when I call this move command, it's sending a message move to this ID, and that ID is actually the ID of the multi-Finch server that you've created. And so it's saying, hey, this is my ID, the client ID. I want to send a move command to move in this direction, at this distance, at this speed. So every Finch command in the client side, if you edit it, you'll actually see a message sending kind of block in there. So again, this is all made of blocks, so it's editable. You always have the backup of having the clean files on our website, so feel free to play around, and if you mess something up, just take a new clean file from the website. So that's just about all you need to know in order to make the Finches work. I'm excited to hear about your journeys and what you do with these remote robots. I'd love to find out more, so please contact us if this is useful for you and if you're using it. And thanks, and yeah, enjoy the robots.